Hey guys, and welcome back to a new backend crash course for beginners, specifically around logging on the backend side with Spring Boot. As you maybe know, logging the right way matters a lot for backends because very often we have some sort of issues. Maybe you get a bug report from a user. The user says, hey, I did these things and then something crashed, something did not work out. I did not get the result that I expected. And then you, as a developer, have to trace things down, and that only works by having good logs. And I can already say that this logging crash course will go beyond simple console logs. So that will be a part, of course, here if we run such a Spring Boot backend, then we get all those log statements here in this case in our IntelliJ console. But I really just want to show you a setup here that is production ready. So with best practices for production mode, with having solid console logs here, but most importantly also taking those logs and logging them remotely, specifically here with Grafana Loki. So that is a cloud service where all of our logs will also be pushed. And that will just make it much more easy to find and query certain logs, because you can imagine for a production backend with possibly thousands of users, these logs here can grow really, really quickly. And then you just need some ways to easily filter these out. I will then show you how you can change the entire logging config. So this logging schema here, the format, how a log message actually looks like. I will show you how you can implement rotating JSON file logs, which is also a very common practice, so that you have chunks of logs in JSON format. Why JSON format? That's something I get to later in this video. This crash course will also be almost programming language independent, because most of the stuff we will write and set up here is just Spring Boot specific and has nothing to do with the programming language you choose, so Java or Kotlin. There is one simple part that we need to really write some code for here that will require some Kotlin here. That is the language that I chose. But also, if you're a Java Spring Boot developer, you can perfectly follow through this course, because 90 to 95% of this video is really independent of the language you choose. All right, so what is actually the project that I've opened up here? This project comes directly from my Spring Boot Kotlin crash course, which I will also link down below in case you want to learn how to build this. But I just wanted to start off with a somewhat realistic example where we can now see how we can integrate proper logging in this. If you want to follow through with your own project, then this will also work perfectly fine. If you just care about the specific part, you will find timestamps here down below. So let's dive right into it and start very simple. And that is just to make a normal console log. So how we can do this in any type of Spring Boot class, or in other words, in any bean. Well, if we go, for example, inside of our Auth controller here, then a typical practice here on Spring Boot is that we have one logger per class. So each logger has a specific tag that is associated that we can then later on use to find out, okay, that is actually the class where the log statement came from. So we also get a first hint where to look for an issue. And that works not by typing a double hashtag here, but actually by creating this logger reference here as a private member field of this controller in this case, but this could also be a service, anything, any kind of bean in the end, where we say logger is equal to, and you can see it already gives us the auto suggestion here, this.java class, alt enter here on this logger, and we want to import this from SLF4J. That is the logging framework that we want to use from Spring Boot. What we pass in those parentheses here, so this.java class, that really just relates to this auth controller object here, and specifically the class reference. So in our logs, we will then see auth controller here as a tag when using this logger inside of this controller. And this is something we could already do. For example, here, when we register a new user, we could say we use this logger, and then we log something. And as you maybe know, there are different log levels, how dangerous kind of something is that you want to log, how important it is to look at. So the most important log is the trace log here. Then the next level would be debug, then info, then warn, and then finally error. So if really an exception was thrown and you want to log that. In this case here, we maybe just want to say, hey, a particular user actually registered. So we could say that's an info log because it doesn't necessarily require our attention. But maybe if this particular user would then report a certain bug to us, they say, hey, I actually registered and then this kind of issue happened, then such info logs can also later on help us to actually trace down what a user did in which order to know how to possibly also replicate this. So here we could say something like, a user registered, and well, here we could of course also attach certain parameters from the body, but here in this case we only have email and password available. Neither is something that I would want to include in real logs, because both the email and especially the password is very sensitive data from the user, which has nothing lost in logs. However, what you can definitely include in logs is something like a user ID from your DB. So that you can include information here that would help you to trace down which particular user something happened to, while not immediately revealing some sort of personal data that you could immediately use to identify this user without even having access to your database. But that's actually everything I want to show you for now, that we can log those info logs here, for example, or debug or whatever. If we then launch our Spring Boot backend and we then go to something like Postman in order to simulate a REST call, then you can see I already prepared a little post endpoint here that fires to my local host, that is the port that my backend is running on, and specifically the register endpoint. Here we can then register with some kind of email and password. And if we then fire this off, then you can see we get this OK as a response. If we take a look at IntelliJ IDEA, then here's our auth controller with a log a user registered. Well, in this case now, this would fire in any case where we hit this register endpoint. Also, if you don't want this, which we wouldn't in this case, if we only want to log the success case, then what we can do is we can say, we move this log after the register function, because if something fails, then this register function here, or this register function, I'm not sure, would throw an exception and the code would not reach this point. Let's quickly verify this, rerun this, and we perhaps go in here, we try to register with the same credentials, so that should throw an error. You can see conflict, going back here, and in this case now, there is no log here, since we hit an error. So this is how standard logging in Spring Boot works. However, very often you want to configure that in some way, because it's not just typical that you want to have your own logs here that you explicitly log in your code, but it can also be that you add certain libraries that already come with logging. Best example in this case here is MongoDB. So for this particular backend, we are connecting to a MongoDB backend, a remote database. If we launch this, you can also see a lot of those logs here coming from MongoDB. And very often we also want to control which logs certain libraries are allowed to fire. And this is something we can configure here in these application properties files. So if we open this up, maybe you also have this as a YAML file here, then the config will be the same, you just have a different syntax for that. So this would be a place here where we can define different log levels on a per package or even per class basis. So we can say, this particular class and all logs coming from it should only log from the warning level and up, for example. However, very often the logs that we actually care about differ depending on our environment. So whether we are currently in development mode or in production mode. Because if you're running your app on production, then you very likely don't want to include that many debug logs like here that don't really add any value, that maybe just occupy a log storage in your cloud provider that make you pay more money without providing any value. So for production, we very often just want to include logs from, let's say, warning and up, and maybe our own info logs that we make in our code directly. While in development, where we just often have to trace things down directly, we typically want to care about those debug logs, about those info logs, maybe even from those external libraries like MongoDB. And this is something we can set up with Spring profiles, and that works by just defining separate and multiple of those properties files here, one for each environment. And that is what we'll do here. So we will copy paste this application properties file and call this one application dev properties, which will only contain those properties that we want to apply during development. And here we can get rid of everything here because this normal application properties file will remain. This is what contains the shared config that applies to all our profiles. But in our dev profile, we now need to say Spring activate on profile. And here we say dev. So the moment we want to use this dev profile, we say, hey, dev is now our active variant. And then this properties file here will activate automatically. And on here, we can set up which logging config we want to have in development mode. That works with logging, that a level, and everything that comes after level now references a specific package name. So we can, for example, say the root logger has the info level. So that means for the root logger, the kind of the parent logger that all other loggers inherit from, that uses the info level and up. So the debug and trace level in this case would not be included in our logs. If we set this to warn, for example, and we say let's go to application properties and say the default profile is our dev profile. Profile default is dev. And we then launch our project. Then you can see we get a lot less logs, specifically only those warning logs here, because we've set the root logger level to warn. So you will only get warnings and error logs. However, that is usually not what you want to do generally. Very often you have some sort of libraries or so where you want a bit more fine-grained control over your logging. For example, MongoDB. What we can now do is we can define a more fine-grained log here just for a specific library, just for a specific package. That works by saying log level and then simply appending the package name of the package that we want to set a log level for, a minimum log level. For example, org.springframework data MongoDB, and then we say, okay, the logs from any class inside our MongoDB package, that should use the debug level. And if we now relaunch this and take a look here, then you can see we actually get some debug logs, but just from MongoDB. For all other logs that aren't directly coming from the MongoDB package, we are still only showing the warning and error logs in our console. The same you might want to actually explicitly set to debug for the Spring Framework, so org springframework.web, which may then include certain logs like for requests, which data has been sent. These kinds of things are usually very valuable in debug mode. And for the root logger, I also wouldn't set this to warn for the dev build, but actually to info. So by default, you see all info logs. If we then launch this once more, then this is now how our logs would look like in development mode. In production, and for production, we want to take this application dev properties file, copy paste that once more, and say we have a production properties file. Here we want to replace dev with production. And for production, as I said, it makes sense to actually just include logs from the warning level and up. Unless you maybe have some of your own logs where you say, I want to at least include all my own info logs, but all external logs from libraries from warning and up. Then you could say logging level, and you specify your own package name. So here in this case, compile coding, Spring Boot crash course, and we set the log level here to info. Then our own info logs would be included, but external logs only from the warning level and up. Then here for Spring Framework web, so those request logs, let's just include error logs. Same thing for MongoDB, because otherwise we get a lot of those MongoDB debug logs. And then if we actually switch to the production build, we can either do this here by switching the default, but you can also go to your run configuration, edit configurations, and here for active profiles, you may need to click on modify options in order to see this. But then you say the active profile is production, click OK, you relaunch this, and then you can see a lot less logs show now up because the production profile, this one here, is used. You can see we get info logs, but only from our own package, so from our own Spring Boot class here. You can see that definitely comes from our own package. And also, if we would now register a new user, then this log here would actually also show it's an info log, but it comes from our own package, since that is what we want to see. So this should already give you a basic understanding of how logging is like and how you can really configure your logs for different builds. However, this is by far not what I want to show you here. The next steps are, I want to actually set up a logging in Grafana Loki. So I can maybe just give you a quick demo of what this looks like. Here, this is a cloud backend called Grafana. And here you can do a lot of cloud-based services. You can use a lot of them. But here's also drill down logs, which give you logs for a specific backend. So if you click refresh here, then okay, from the last 50 minutes, there aren't any. But if we say last 24 hours, last 12 hours, then we can see all those logs from our apps here directly in the cloud in our browser. So you don't actually need to look into your terminal, into your console, where you don't really, we're not really able to filter those logs here and query them. So this is how this will look like later on. Those are all development logs here, but if we open these up, then you can see all those logs are indexed. We can attach certain data to them. And then you can filter for logs much more easily by taking a look at those labels here. Actually here, filter fields. Just say, okay, I just want the error logs and the warning logs. And here you can filter by label values. You can say, okay, the environment should be equal to development. In this case, I only logged with the development. But you can see this way you can you really have query potential for your logs, and then you only get those warning and error logs, which really helps you to trace down things. Here you can then search in log lines if you're looking for a specific user ID or so, and then only those users will show up here. This way you can also see the log volume here. So for example, if you have certain log spikes where they're coming in a lot of logs at once, then this maybe hints towards something that went wrong, doesn't need to, but can. And in such a cloud provider here, you'll just get much, much better insight. And what I will show you here is also completely free for, I think, 50 gigabytes of cloud storage, of storage for your log statements, which is definitely enough for this crash course. But in order to set this up, we need to first of all head back over to IntelliJ inside of our build.gradle file, because we need to add some more dependencies here in order to make this work. And I will paste these here. You can find these dependencies down below in my GitHub repository, so you can also just copy paste these. On the one hand, we have a Logback classic that will allow us to actually have another XML file specifically that lets us configure different types of loggers. So also how our log messages are formatted, which colors we want to use where, these kinds of things. We then want to use the Loki Logback appender. So Loki is the cloud framework here from Grafana that we use. And this appender will automatically take our logs and send them to our cloud backend after we've configured it in our Logback file. And lastly, we will use the logstash Logback encoder, which will achieve this rolling JSON logging. So we will have another folder here that will automatically be generated where JSON files will be stored with each log statement be put in a single JSON structure. So we can hit here, reload, and then we can get started with this. All right, what do we get started with? We want to get started with creating this Logback XML file here in resources by just right-clicking new file, and we call this logback-spring XML. That is the file we want to create. You can get started with the XML UTF-8 config, which is just the header line for every XML file. And then we want to place a configuration file in here, or configuration tag in XML. And specifically, I want to paste some namespaces here. So namespace is in the end just something, a URL where IntelliJ can look up for specific auto suggestions here for syntax highlighting for this file, since the tags that we will use here, IntelliJ won't be able to detect by default. I will paste those namespaces here. Of course, you don't need to type these off. Again, GitHub link is in this video's description, and you can just copy paste this header here. But it's in the end just a URL where IntelliJ looks up to get this information about which XML tags are applicable in which context. If you're doing this for the first time here, you may need to actually hit Alt-Enter, and then maybe after completing this tag, hitting Alt-Enter here, and then there will be a sign that says fetch those namespace attributes or so. So IntelliJ explicitly needs to download these, and then you are good. But even if something in regards to this namespace does not work for you, you can still follow through here. This won't have an impact on production and on runtime. But in that case, everything in your file would just be marked as unresolved reference and in red. What do we now do inside of this configuration tag? We want to define multiple of so-called appenders, so log appenders. A log appender is in the end just nothing else than a destination for logs. So where logs should go, or a way to intercept logs and then do something with these. So one very prominent log destination would of course be the console. But as I've already teased, we want to have multiple of these log destinations here in our project. Specifically also, apart from the console, we want to have the Loki destination, so our Grafana dashboard, and we want to have the JSON files as a destination. And that is what we will now set up here. And we can define these with the appender tag, where we can then specify a name and a class. Here we, for example, have the console appender. So this will then set up and configure our console-specific logging. For the class, we need to link a specific class from our project or from a library we use. This comes from chqos logback, so our logback library, .core, and we call this console appender. So this comes from our library already. Inside of such an appender, we want to have an encoder tag, so something that kind of serializes our logs if we want this. Here for the encoder for the console, we can reference a class that really does the encoding, which also comes from the same library, in this case, classic data encoder pattern layout encoder. So this will really just use a normal default log line. Inside here, inside of the encoder, we can then specify a pattern for our logs. So in which format we want to have those logs here, so that we first maybe want to have a timestamp, and if we want to have one in which format, how detailed will the time show, which level, which kind of port probably that was called on, then in which class this happened, what the actual log was, and so on. This is what we can define in this pattern with predefined placeholders. For example, %d references the current date time, and then we could say dash message to show the actual log message. This is now a super simple log. I really just do this for a quick demo here to show what this really does. Down here, we want to say root to configure the root logger here, for the info level to just link specific appenders here from this file inside of our root logger. So we can say we reference an appender with appender ref, and the ref is simply console, so the name we chose for this appender. And this is then linked to our root logger from the info level. If we launch this, then we should already see our logs being in different formats. We are still in production mode. Let's quickly switch back here to development, relaunch this, and that's interesting. What you see here is all of our logs are printed in a single line. That already shows that it's working what we did. It's not what we intended, but it's because we forgot this %n, which will add a new line after the log. Add this and then take a look again. Then, right now, we only get the date timestamp and then the log. So we dropped all the remaining information about the level, about the port, about the class this comes from. So you can see this is how you can change the pattern of your logs for specific loggers, for specific info levels or log levels in general. It's of course not what we want to leave our logs at. We do care about all that other information like the log level, which we can add with a percentage -5 level. So -5 will just achieve that the level is always padded to the left by 5 characters, regardless of what the level is and how long it is. We may want to attach the logger, so that will then include the class reference where the log is coming from. And if we relaunch this, then this will already look a little bit better. Here you can see now we see the log level is always padded here. So the class always starts at the same kind of column here. And then we see our real logs. You notice that with the setup, we've actually lost our colors of these logs. That's of course a bit convenient to browse through these logs quicker, to just mark certain logs in different colors depending on the level. That's something we can also set up here, but for that, we need to include something here. Specifically, I will paste this resource here, which comes from the default XML file for Logback from this Spring framework. So there is a default config, and we can include this here to get access to colors. And what we can now do is, in order to highlight certain parts of our pattern here in a different color, we can say percentage color, so CLR, and then what comes in parentheses afterwards, that will be marked in the color for this corresponding log level of that message. What we can also do is, after the new line, we can say we have a color, and then we open a parentheses with percentage WX, and after that, a new line again. So what this will do is, if there is an exception, then we will show the exception highlighted in the color level of that log. So for an exception, typically in red, because it's an error. And if we relaunch this now, then you can see we get back our logs. It looks a little bit different than before, because the default is that just the log level is marked in the color. But now we also see the class name here, for example. That's of course completely up to you what you prefer here. Just for some reason, we see those percentage new lines here. I am not sure why, but maybe we need to drop this. If that is the cause, relaunching this, yeah, now it's actually left there. But if we now actually throw some kind of exception here, for example, in our application, we delay this a little bit because logging always needs a little bit of time to set up. And so I'll just use a coroutine here, delay this for 5 seconds. And then I can say we have, let's quickly get a logger here, logger factory, get logger, and we say, I don't know, main or so. And then we have an error log, fatal error, and we log runtime exception fatal. If we do this and then wait 5 seconds, after 5 seconds, we should get our exception. Yep, there it is. You can see big fat red exception because we have now added this to our logs. It's printed a little bit separately here, which is nice and improves readability, I think. So we've already improved our console logs by quite a bit, I think. Next up, I want to go into sending all those logs to Loki so that we then also see them in our Grafana dashboard online. And for that, we need to define actually not just one extra appender in our Logback Spring file, but 2 of them, because one of them is actually optional but very recommended. And that is a specific async appender that will make sure that our logs are buffered. So with a given buffer size, we store them in memory and then send them in chunks to our Grafana dashboard asynchronously. So on a background thread, this will make sure that even if you have a big bursts of logs, that this will not slow down your network traffic, your responses from HTTP, and so on. So we want to define an appender here, first of all, called async Loki. So again, Loki is the remote logging framework that we use here, but this could be anything. This could be AWS, CloudWatch or so. That's really up to what you prefer. And here we say again, chqs, logback, classic, and we say we use this async appender. And here we don't get auto generation for all those fields that we want to mark, but they will still exist and work at runtime. Specifically, the queue size is something we want to define. So just the size of bytes of logs that we want to store in memory. And I will say 16,384. So about 16 megabytes of logs that we want to store in memory here and then send to Loki. Next up, we want to define a discarding threshold, which I will set to 0 here. What is the discarding threshold? Well, you must imagine the moment we actually add the logs here while using this async Loki appender, then this buffer here will fill up the more logs we actually have. In the background, it will keep on pushing these logs to Loki here whenever it has a chance, whenever the background thread actually gets some CPU time. And the moment we push them to Loki, then this buffer will also, of course, shrink in size again, because the moment we know a log is successfully pushed, we don't need to keep it in memory anymore. Now, it can, of course, be that you have a huge burst of logs at once, and this buffer would exceed this buffer size. Then with this discarding threshold, we define what happens and from which point we want to handle this kind of buffer overflow, because it can't really overflow here. But if we say we set this to 0, then the moment it overflows, what this async Loki appender would simply do is it would drop all remaining logs here and not send them to Loki. You could also say you set this to 20 and then it would start dropping logs for the remaining 20% of the buffer when that fills up, but prioritize dropping those not so important logs. So debug logs, info logs. So it prioritizes based on the log level. Now, this sounds super dangerous here that logs can be dropped, but you must imagine that this is 16 megabytes of logs, and it's quite rare. And I also chose this buffer size because you first of all have to have a scenario where you achieve having 16 megabytes full of logs before being able to send any of these to Loki. If you're still afraid that you could make this buffer explode here, you can of course increase this buffer size, and then you will just store more logs in memory and reduce the risk of having to drop logs here. But if we set this back to 0 here, then we make sure that it will only drop logs the moment this buffer would be exceeded. Next up, I want to set never block true, so that when this buffer is full, it won't block the thread where the log statement is made on, but rather drop these. If this is false, then logs actually won't be dropped, but then you will wait and block the code where you are currently making the log when the buffer is full until there is space in the buffer again. So it means if someone is currently making an HTTP request to your server, you log this and you set never block to false, and the buffer is full during that HTTP request, then the response will be delayed because Loki will first, or the logger will first of all wait until the buffer has enough size for the new log in that case. That's also up to your preference of what you actually want to achieve here, of course. And then we want to say we have an appender reference in here called Loki direct. So this will be another appender that we define next, which directly sends all our logs to Loki, and in combination with this async Loki, that will just happen asynchronously. And in order to set up this Loki appender, we say appender, call this Loki direct, same name as we've referenced here. The class name will now be GitHub Loki4j. This comes from our library we've added previously, Logback, and here we have this Loki4j appender, which we want to use here. And in here, we now need to configure pretty much the config of our Grafana Loki setup. So where to which specific remote server with which credentials these logs should be sent. This works with an HTTP tag. In here, we want to have a URL. Oops, not URL, but URL. And we want to define an auth tag in which we specify our username, so our credentials that we will get in a moment, the password. In order to get this data, we need to head over to Chrome or your browser of choice here in Grafana, and you need to go to connections, add new connection. Of course, you need to create an account here on Grafana first, so grafana.net, and then create a free account there. And once you're logged in, you will see something like this. Then go to add new connection. Here you see lots of different destinations for certain data that you might want to have here and store, like MySQL and so on. What we want to search for is hosted logs. You can see this is what we want to add here. We click on that, And then we say send logs from a standalone host. Need to then generate a token. We can give this policy some kind of name, or this token rather. We say, I don't know, logging token or so. Or we say Spring Boot crash course token. We then click create token. And then you get something like this. This URL here is technically a secret. You will see my details here because I don't want to blur this. But I will just delete this connection afterwards. So you can't do anything with that. What do we see here? We see a URL that we can now send logs to in Grafana. On the one hand, this consists of a user ID, username, and a specific token that in combination we can then use to connect to this specific URL. So let's take this user ID and we want to extract that into an environment variable in IntelliJ. So we go to our edit configurations, and here under environment variables, you see my JWT secret already, the MongoDB connection string, and you would just want to add a new one here. You maybe also need to click on modify options to show this environment variables tab, but then click here, add a new one, call this Loki user, paste in the user ID, go back, take this token together with the double equals here, copy this, and here you want to then also create a Loki password. Or let's call it Loki token because it's rather token. Paste this in here for the value, click OK, click apply, OK. And going to Chrome once more, we now want to copy this entire URL, copy this, go back to IntelliJ, and here for this URL, we paste this, but remove everything before this add. So this token and the user ID we can remove here from this URL. So you just see this logs, production, blah, blah, blah. And here in these fields, we can then reference environment variables with a dollar and curly braces, specifically Loki user. And, oops, I removed the angle bracket. And Loki password. And this will then be replaced during runtime with the values we've set before. But this way we don't include those sensitive data in version control. Now this will be enough to actually set up our logs and actually already send these to Loki in chunks. But the thing is, such a remote logging framework, we typically want to just attach some more data to it, because a big benefit of these remote logging frameworks is if we go to drill down logs and take a look here again, I've shown you this before, but for each log, there are lots of these fields being attached that will later on help us to trace down or to actually get information about certain extra data. For example, what I will show you in a moment is how we can by default attach every single user ID to such a log statement if there is a user ID. So if a user is logged in and the user maybe retrieves all their nodes, and we log this, that the user ID of the user who retrieved their nodes will automatically be passed here. And this is why this is so helpful and why it makes sense to configure this a bit more here to define which data we additionally want to forward to Loki. So below this HTTP tag, we're going to have a label tag. And again, label like this. Again, this will be unresolved here, but you can ignore this. And this label tag actually must go in a format tag. So we say format and then move this label tag in here. And now we need to distinguish between labels, so extra data we attach to a log statement that we can always attach as kind of a constant. So values that don't change across the runtime of our app, like the name of our backend, like the current environment we run it on, like development, production. That is something we can put here in label by saying simple key value pairs app is equal, so the app name, dollar, curly braces, and we say spring, not in there, but here, spring application.name, and with a colon dash, we can say, we define a default name if that doesn't apply. For example, Spring Boot crash course. And the environment is something we may want to attach, which is also a placeholder from spring profiles.active, and we default this to production. And this actually must go in pattern, sorry. So we put this in the pattern tag, move this in here, take this, move it in here. But then additionally, we also want to have a so-called structured metadata pattern tag. So Loki consists of two types of labels. If we take a look here, they're actually so-called just normal labels, and we have those metadata tags or metadata key value pairs. The normal labels are meant to only be used for so-called low cardinality values. Sounds very complex, but in the end, low cardinality just means you have a very limited set of, a small limited set of options. So for example, gender, you have 2 options here. Nowadays, I don't know, but you get the idea. For example, the environment, you just have production and development there. For example, the log level, you just have 5 different distinct values, and you know these will never grow, the set will never grow. On the other hand, you have certain values that you may also want to include in your log statements that are much more various, like for example, this user ID. Every single user has their own ID, and therefore, in all log statements in total, we might store thousands of different user IDs. That would not make sense to store in such a normal label, but in such a structured metadata field. These differences just make sense because the normal labels are indexed by Loki so that you can query them easier and more efficiently, while still being able to actually search for the remaining fields, and just not in an indexed fashion in that case. So here we can define those by saying level is equal to the log level. This will automatically be replaced. Here actually I'm also missing a comma. You need to comma separate these. We may want to care about the thread that a specific log statement was executed on. This will be replaced here. We may want to care about the class. So that comes from the logger placeholder. We may want to have some kind of trace ID if you have that in your logs. I will leave this out and I will include the user ID, however, which I will show you how we can attach that dynamically to our log statements. And here we will say %MDC and then curly braces, user ID, and if it doesn't exist, we set it to none. What this MDC means, you will find out in a moment. Below this label block now, we want to have a static labels block that we set to true. So this means all those labels, patterns, and metadata will just be evaluated once at startup, and then that will never change. And then lastly, we say message with a class tag, close this off here. And here we need to define the class for the actual encoder, or just how we want to serialize those logs. That is Loki's way of doing it. We can set this to com GitHub, Loki for J, Logback, and here we can choose the JSON layout. This will pretty much just mean that our logs are being sent to Loki in JSON format. Why would this be useful, and why is this actually a very widespread way of logging in production? Well, the thing is, if we just run our app normally, here you've seen this, technically every single log is really just a plain string. But if we want to filter logs based on specific data, if we want to have a real structure in our logs that we can look up in, then we need a better or an alternative approach of storing our logs. And if we store these logs as JSON, as you've seen here, you can see all those logs are effectively being stored as JSON strings. Then we get all that information that we can easily parse, and that is also a very universal format. So you can, if something changes about your cloud provider, for example, you could really just take those logs and import them in another cloud provider, and they will all support JSON logs in some way. It's not the native format from Loki, but it's still something Loki supports, and you can see we can achieve really easily. But what you choose here is of course up to you. So going back to IntelliJ, we've now in the end defined this appender here, the async one and the Loki direct one. The async one references our Loki direct one. So if we now say we take this async Loki appender and we reference it here for a root logger as an additional appender ref, async Loki, then this will really take all our logs from the root logger from the info level and also send them to Loki and additionally to our console. If we now run this and then also see our logs here, then this usually takes a little moment. And I think here in this case, it may not even fire these logs. It will probably. Let's wait for a moment. And meanwhile, we go to drill down logs to the base tab. And if we refresh this here sometime, we should maybe see an additional service. We don't, but I got an error actually here that my authentication details apparently were incorrect. So I will check this. So you can see it takes a little moment for Loki to actually log or send these recently logged logs to the cloud provider, to the cloud backend. I will need to check why this error is actually there, because I just copy pasted my token, but I will see you back in a moment. And well, what should I say? On the one hand, I have a typo here, so this closing angle bracket should not be there. And I also named our environment variable differently. I didn't name it Loki password, but Loki token here. Maybe you've spotted that already, but then of course authentication fails if it retrieve the value of a not existing environment variable. Another thing that I actually want to change here is this URL a little bit, because the URL that Grafana Loki actually gives us is a deprecated one, actually an older one, which it probably gives us for compatibility reasons. But this URL with this API route does not support JSON logging, specifically this prom push endpoint. And we simply want to swap this out to grafana.net/Loki/API and then reference v2 of that API. So this is the URL that we want to talk to, and this is also the one that supports JSON logging. And then I would say we can restart our backend, and then hopefully we see some sort of log here that successfully sends a chunk of logs to Loki. So this is how this works. It will just wait until there is some sort of logs here that can be sent, and then once every while they will be sent together to Loki. But that always takes a few seconds here, 30, 40 seconds or so. So let's hope for the best. So for me, the log at least is not coming here. Maybe this is also excluded from our filter in some way, but we can still check in Loki whether these logs arrived by clicking on logs here and refreshing this. What is this? This is our Spring Boot crash course. Here are our logs. That is looking really good. So if we click on show logs, so make sure to be on drill down logs here in Grafana, then you can see all those logs from 9 a.m. here, which is actually exactly the time. And here are our logs. I mean, if we take a look in IntelliJ, I'm not sure why the log that Grafana sent this here was excluded. I think we may need to enable debug mode in order to see this, which we could do here for configuration by setting debug to true. But you've seen it works either way. So if we just take a look, for example, for the last log here, started Spring Boot crash course application in 2.6 seconds, then we can also find this log here. You can see this now has a JSON structure, so the actual log message is formatted as JSON. The message itself is therefore not that readable, like a normal plain text. But if we open it, then the big advantage of JSON logs is that we get these different parts of that log statement as isolated key value pairs, which is of course very useful also to later on map and filter on these. So we can see on which thread name something now happened. We can see the service names of our app. We can see the log level, the environment. We can see our logger, so in which class we've actually made the log statement. In this case, this was, of course, Spring Boot itself. And the actual message, of course. And this is now, of course, much, much easier to filter these logs. We can filter these here by label values. I don't know what we have here. So we could say, do we have the message here? Yes, we can filter based on the message. And then you can see we can check if the message is equal to something. And you can also see we get a lot of auto suggestions here already. So if we take this security password line here, for example, this is only for the debug build, but then you can see we can perfectly filter based on these. We have a warning log here, see those messages. So this is much, much more convenient than actually having to browse through these logs in your service console. What you can actually also do is you can go to Explore here on the left side, and then you have a little bit more fine-grained view to query your logs. What we can do here is we can first of all make sure that we have selected the right project, or PL coding logs in this case. We can then actually get the live stream of our logs. This is also sometimes very useful. And then we need to select some sort of filter, like say, hey, for the app, we want our Spring Boot crash course, and then run query. Then right now, nothing will happen because our backend is running. Okay, for some reason, I had to stop this live mode here and then click run query. Then you can actually see those logs. But if we now say live, then the new logs should also appear in live. Actually, the newest logs here are at the top of our window. But now we would actually listen to logs in live. So if you're currently debugging something and you want to find out what goes wrong, then this tab here really helps you with that by seeing live changes of your logs. So this is how we can really connect our backend to Grafana. However, what I showed you in the previous demo, and what I also want to show you, what one big advantage of Grafana is that we can now add those labels, and we can add custom labels as well, which can be super useful. For example, what's very common is that in your project, you have some sort of user authentication. Just like here, this is simply a node backend where users can register and log in. And if they're logged in, they just have a set of nodes they can create and own. And if a big part of your backend infrastructure is actually consisting of routes that are authenticated, where the user maybe attaches some kind of token or maybe JWT token, like in this case, that actually keeps information about the user. So here, if we open our node controller, then you can see the moment we call the save endpoint to save a particular node, then the user, of course, needs to be logged in for that. Then we need to retrieve the owner ID, so the ID of the user, from our security context in order to then attach this to our actual node we save in our DB. This is, of course, also what we can use to automatically intercept our requests and attach the ID of the user who made the request while retrieving it from our auth token, attaching that as an extra field to our log statements. Of course, there is not always an ID from the current user that we can attach to a log statement, but whenever a user makes a log to an authenticated endpoint, then we know we have that. And then we can also filter based on that user ID. So maybe someone approaches our customer support and says, hey, I actually had issues with saving a node, for example. And then we can take their customer ID, filter based on that in our log statements, and we just see logs from that user. That is super useful. So how can we set this up here with Loki? The magic word is MDC, or in other words, Mappings Diagnostics Context. These things always sound super complex, but it's in the end just a map, so key value pairs of data you can attach to logs. And with this MDC, we can simply change and adjust such custom fields for our log statements. And since we want to do this for each and every request, we can go to our root package here, create something like a logging package. And here I want to create an MDC filter class. And this will implement the filter interface here from Spring Boot, from Jakarta Servlet. And then we need to override, so Command I, this do filter function. So here in this do filter function, this is in the end a function we now want to execute for each and every request that is made to our backend. I'm just renaming those fields here: request, response, and chain. So this will be executed for every single request a client makes to our server, and that's of course a perfect place where we can say we take the ID of the user and simply pass it to our logging context just for that request. And this works with a try and catch block. Here we retrieve the user ID, which we again try to get from the token. You can see the AI already suggests it, which is exactly what we want. I just want to make this nullable, since as I said, it may not be available, or I think it actually always is available here. But if there is no particular user ID that we set to this principle, then this will be anonymous user or so. So I think we should also be fine leaving this as non-null. Now we can say MDC here from SLF4J dot put, and we want to put the user ID field and specifically our user ID value into it. And then we can say chain dot do filter. So we simply proceed with this chain that possibly goes over more of these filters and pass in our request and our response. And in the finally block, we say MDC.clear, because of course, we only want to set this user ID field here to our MDC only for the thread that executes this request. And after having proceeded with the request, after having really responded to the user, then we don't know that the next request will also be from the user. So we need to clear it again, that we start off with a fresh new user ID for the next request. Now with this MDC filter alone, nothing will happen. Instead, we also need to create a logging filter config. So this is just a Spring Boot bean that will really apply this filter. So we annotate this with configuration. And then we say we have a bean in here, which is nothing else than a function for the logging filter. And this will return a filter registration bean of type MDC filter, because that is the type of filter we want to apply here to our Spring Boot backend. And in here we can really just return a filter registration bean and then set this up. Oops, not with MDC filter. That is what comes afterwards. We set this up here, set the filter to MDC filter in here, and then we say we add URL patterns for which URLs we actually want to apply this filter. And well, in our case, that is /auth. No, actually, let's just make it for everything. Then this will also include the auth URLs, but for those it will say anonymous user. And this alone will be enough in order to apply this MDC filter to each and every request. So if we now actually relaunch our Spring Boot backend, we can of course test this. There we go. If we now go to Postman, and here where we really have access to our backend, where we can make requests, we can now test this so that we now take those new credentials here that we've created and try to log in with these. So we get a token that we can then use to create a node, for example. Where is that? Can we log in here? Yeah, auth log in it is. Then we say this is the email, pass in our previous email, test6@test.com. And the password was test12345. If we do this, we get a token back from the API. Yes, the access code token, there it is. And with that, we can now retrieve our nodes. That is actually not the right endpoint, but we can just say /nodes. I think this should be the endpoint. Quick check in our node controller. Yes, /nodes endpoint. And we want to find all nodes by owner ID. That is the get mapping. Perfect. This won't retrieve any nodes here, but it's an authenticated route. So we definitely need to attach a token here. Authorization. We say bearer, pass in our access token. And other than that, it's simply a GET request. So if we fire this off, then we get OK here. And I think what I forgot is actually having a real log. So let's quickly go to our find by owner ID function and say we make a log here with our logger that I haven't created in this class yet. So private val logger. That's logger factory, get logger, and we reference our node controller class. That is fine. And if we then say logger.info, for example, and we say retrieving nodes or so. And possibly we also already see some kind of request. Yeah, I mean, we already have logs that correspond to this request. You can see we have these debug OK logs. So that may already be enough. If we now go to Chrome here and on our logs window and we refresh this, then we see our new logs. And now here in our fields, we should be able to look up user ID. And you can see it actually prepended MDC here since it got that from our MDC context. If we click on that and we say, okay, that is equals to something here. Okay, it suggests that. You can see there is one user ID. And if we do this now, then we see all logs where this particular user with this user ID actually made a request. So this is now much, much easier to actually trace down these issues and what the user did. You can see the find by owner ID was called from this user ID here. We can see that this user actually used the nodes endpoint. So a lot of information that is very useful here when it then comes to debugging, to tracing down issues that relate to one specific user. And this, of course, is not exclusive to user IDs. This can be used for anything that any type of information you somehow have available for a big set of requests that you can globally apply via such an MDC filter. You can, of course, also use this MDC logic here to put something in there on a more dynamic basis, let's call it like that. So you can call this from anywhere in your code. But you can see it's quite a little bit of work to actually change such a value here. It consists of at least 2 lines plus a try finally block. But you could use this, I don't know, if something goes wrong, you could use this to attach the available and free RAM of your server to the log statement. So you can attach a lot of diagnostics data to this MDC context to know why certain crashes might have happened, because maybe the server was low on memory. So this is now super, super useful, which is an option that you don't have that easily with just normal console logs. As the last thing of this video, I want to show you those rotating JSON logs. So in the end, what we want here, and this is really dependent on if you want that, but I want to show you this since it can be quite helpful in different scenarios. What we will do is we will set up a logger, an additional appender in our logback file that create a new folder in which it stores the logs, but it stores those logs in chunks, so in different files. And whenever one file actually hits a certain size, let's say 50 megabytes, or a new day is there, then the previous logs will be taken, will be zipped and saved on the file system. And this history of past logs will be kept for 14 days. That's also something we can set. Why could this be useful? Well, on the one hand, it's just kind of an extra backup of your logs in case something goes wrong with Loki, maybe a connection breaks or some kind of quota is exceeded on Loki and the logs actually don't appear there. Then your logs are not lost because you also store them locally on the file system. Then additionally, because we store one chunk of logs per 50 megabytes or per day, this makes it quite easy to browse through the logs and know where to look. So you don't have a log history of tens of thousands of lines, but only chunks of 50 megabytes or per day. And sometimes companies actually also have certain compliance requirements to, for example, say that logs have to be deleted after 14 days. That, of course, also helps a lot if you have those logs on the file system tagged with a specific day where those logs are from. So it's overall just an extra safety mechanism, an extra source where your logs can be retrieved from, which I want to show you here. But as I said, if you feel like this is not something you need in your case, it's totally fine to leave this out. It's not a general thing that you need to do, but I want to show you those different options that we have here with logging, and don't just want to leave this at normal console logging. So here at the very bottom in our Logback file, we say we have another appender, and this appender we call JSON file. The class name is, again, chqs, logback, core, rolling, and then we take the rolling file appender. That is what will do the job here for us. We need to reference the file in which we want to save this, for example, logs/application.json. Then such an appender needs a policy. So the rolling policy, this is what defines when rolling the file should happen. So when the existing file, the application JSON file, where it will consistently write our JSON logs into, when this file will be taken and extracted into a separate file to consider this a finished chunk of logs, and then it will start over with a fresh new application JSON file. And when that should happen, to copy over the contents into a separate zip file, that is what this rolling policy actually describes. There are also existing policies. So here we can say classic, actually core, rolling, and we take this size and time-based rolling policy. So either if the application JSON file hits a certain file size, or if a new day is actually there, so at midnight, it will roll the file and save it into a new zip file. Then here we can pass a file name pattern. So how the zip file should actually be named and where they should be saved. Specifically here in logs, we say application dot, and then we could, for example, pass in a timestamp in, I don't know, year format, then months and days. This is in general a good format for file names because it is ordered by default, so that either the largest or lowest date will come at first. And then we could say .json.gzip, for example. We can then define a max file size from which we want to start rolling, for example, 50 megabytes, and a max history of, let's say, 14 days. So then after 15 days, the first chunk of logs here, the first gzip directory, would be deleted automatically by this rolling policy. And lastly, we can then say we have an encoder, since we want to, again, encode these logs here in this file as JSON logs. We can define the class for this encoder here from net-logstash. So this is our other library that we've chosen, net-logstash-logback encoder. We take this logstash encoder. This will really save those logs as JSON and not as plain text strings. We can define a time zone for these, so that the time zone is independent of the server's time zone, that it's always in UTC. And we could possibly also define custom fields here just to show you these options that we have. Here we can define a JSON structure for things like the service. So here, similar as before, we can make use of placeholders to say, hey, the service is our Spring application.name, and if that doesn't exist, Spring Boot crash course. Trailing quote here, comma, and we could also say we attach the environment by saying, okay, spring.profiles, active, and if that doesn't exist, we say we default to production. And then if we go to our root logger and we also add this as an extra appender, so JSON file, then there should already be everything we need in order to do this, since the actual behavior behind that is implemented in those classes here that come from the library. So if we launch this, here we should see the results quite quickly, since writing to our local file system is of course easy. Logback configuration error detected. Okay. Missing integer token, that is I. Okay, this I, %I is a placeholder we need to put here. So let's say $%I. This will, I think, be the number of this current file roll operation. let's just relaunch this. And yes, now we don't get any more errors. If we take a look here in our hierarchy, click here, then we should see some new logs. Or maybe this also takes a little moment. Maybe we need to right click and refresh the file system, reload from disk. Yes, there are our logs. Our application JSON, which is excluded from version control by default. That's also what you should do, of course. We double click this, and here you can see, we see all those log statements as JSON files. And this is now the file where the logger will keep on writing our logs into until this file hits the threshold of either 50 megabytes or until midnight. So if midnight would now be, if now would be midnight, the contents of this file would be taken, would be moved and copied into another file. This file would be cleared, and all subsequent logs from the next day would then again be written into this file here, into that is then blank from midnight on. And then over time, you just get a hierarchy here of these gzip archives with all of your applications logs, at least 14 of these, assuming each chunk is not larger than 50 megabytes, which helps you to, for example, stick to such compliance policies that you need to keep logs for no longer than 14 days. Just by design, you don't need to manually delete anything there. You don't need any cron jobs on your backend. This is already managed by the logging framework itself. So that is at least in regards to the practical code what I wanted to show you in this crash course. But I still want to also share some production best practices when it comes to logging. Partly I've shared these already in the course here, but here once more as a summary. For production, you definitely want to have some sort of remote logs. You can also use a free open source software for that, but you need a way to actually properly query and filter based on your logs. So for example, if you want a free alternative to a Grafana, which becomes paid at some point, you can take a look at Apache Lucene. That is open source software, which you would need to self-host in that case. So it requires a little bit more setup, but then it's free and you have the full capabilities for that. For production, you mainly care about warn and error logs, so stack traces, warnings, where things might have gone wrong. And I would say the info logs that you made yourself on the backend. Drop the rest, leave out all those debug logs here, where MongoDB also says that it created some kind of index or so. That is really just noise in your logs that does not really make you point towards an issue in your code. If there's really a specific library where you do want those info logs to be there in production, then you've learned how this works here in your application config file for the production mode. You would simply reference the package name, set this to a particular log level, and then those logs will be overriding the root logger level. Then another best practice is to just have one logger per class. So to just initiate these here in your controllers like we did. There is also a library called Logback, which helps you to generate these loggers during compile time. So you don't need to do this. You can just annotate your class with SLF4J. But this library is very experimental for Kotlin classes, which is why I just create these loggers myself. If you're using a Java project, then that's no problem. And you can add the library with the annotation processor that goes hand in hand with it. And one last thing, most important for logging. Don't log anything that you also wouldn't paste in the public chat. So things like an email from one of your customers, definitely things like tokens or request logs that might reveal the token. Of course, things like passwords. So anything you wouldn't confidently share with the public, don't put that in your logs as well. Treat these logs as public even though they aren't. So logging something like a user ID or custom IDs is totally fine, since other people directly can't do anything with just that ID if it got leaked somehow, since they would additionally need access to your database in order to look up who this ID belongs to. But if you're a little bit afraid that you could accidentally log things like a token or a password, then what you can also do with a Logback is you can set up masks. So you can say, hey, if a log message contains this particular pattern, so maybe the bearer keyword appears in a token, then you can define how the actual token will be masked in your actual logs. So just with a bunch of axes so that the actual real token won't be revealed. That's something you need to have a custom implementation for. You need to define your own patterns, what you want to look for as sensitive data in your logs. The best practice is to just make sure beforehand to not even accidentally include such sensitive data in your logs. And if you actually say you enjoyed this and you like the depth of information in this crash course, then you will find another crash course here in which I built exactly that backend where you learn how you can implement Spring Boot with a MongoDB instance to save your data, how you can implement a full authentication system with JWTs, with refresh tokens, access tokens, have proper token rotation. We will use bcrypt in order to safely save the hashes of passwords. So all those security best practices we stick to here in this crash course is completely free on YouTube, I think 3 hours long. So if you say you like these Spring Boot videos, then definitely also check the crash course for building such a backend in the first place. Thanks so much for watching. I will see you back in the next video. Have an amazing rest of your week. Bye-bye.